I welcome you all today to the online tutorial program on further chemistry. Today we are going to be looking at the topic acid. So when we are talking about acid, what is acid? Acid is a substance on which when it is dissolved in water, it produces hydrogen ion as the only positively charged ion. Acid is a substance on which when it is dissolved in water, it produces hydrogen ion as the only positively charged ion. We can also define acid this way. Acid is a substance on which when it is dissolved in water, it produces proton as the only hydrogen ion. Now, if you look at the definition that we have what is called the hydrogen ion. But take note, the hydrogen ion only does not even define the acid. Now, let us now look at what the acid is talking about itself. Take note, HCl is an acid. H2SO4 is also an acid. Now, we have hydrogen here. We also have hydrogen in this place. Now, for that reason, we can redefine acid this way. Acid is a substance on which when it is dissolved in water, it produces hydrogen ion and a negatively charged ion. It produces hydrogen ion and a negatively charged ion. Because in this hydrochloric acid, we'll be having H plus Cl minus on dissociation. That means when they are in aqueous form. Also, H2SO4 on dissociation will produce 2H plus SO4 2 minus. And that is the reason for the definition of acid in that manner. Now, we are all conversant with what is called the organic acid. For instance, acid are found in fruit juice. On ripe fruit, we can find acid there, e.g. the lime and lemon. We also have the citric acid as well. We also have what is called the amino acid. All these are the natural or organic forms of acid. Now, let us now look at the type of acid. When we are talking about the types of acid, we have two types of acid. We have organic acid and inorganic acid. The inorganic acid is also known as mineral acid. Now, what is organic acid? Organic acid are those acids that occur naturally in living organisms. Like it can be found in plants, it can also be found in animal. A sample of acid in plants is the citric acid. We have the lime and lemon. They are the one that we have there. A sample of acid in animal is when we are talking about the amino acid, we are talking about the fatty acid. All these are the examples that we have there. Now, let us now look at the examples of this mentioned acid. When we are talking about the organic and the inorganic, we have the following example there. Under the organic, we have the citric acid, we have the amino acid, we have the fatty acid. They are the examples that we have here, but to mention few of them. But when we are talking about inorganic acid, here we are talking about hydrochloric acid with the formula HCl. Also, we also have sulfuric acid. H2SO4. We also have carbonic acid, which is H2CO3. All these few mentioned examples here, they are also the typical example of inorganic. We can also add HNO3, which is also called the nitric acid. They are the examples here. Now, since we have looked at the examples, let us now try to look at what is called the strength of acid. What is strength of acid? Since acid ionize, that means they are ionizable, then we have the area of their own ionization in terms of concentration. So under the strength of acid, we have two types of acid. Under the strength of acid, we have what is called the strong acid, and we have what is called the weak acid. The weak acid. Under the strength of acid. Now, what is strong acid? Strong acid are acids that ionize completely in water. That means they ionize all the molecules that are present in them completely in water. All the anions, they discharge everything into the water, and they are said to be what? To be strong acid. Example of strong acid, e.g., we have HNO3, the nitric acid, we have HCl, the hydrochloric acid, we have H2SO4, sulfuric acid. They are typical example of strong acid. They ionize all the molecules present in them completely in water, and so they are strong acid. And that is why they will tell you in the laboratory that what's called conch acid are corrosive. So if conch acid are corrosive, that means you cannot play with them. They are dangerous. When they splinter over your body, they can burn your skin, your eyes, any part of the body that they affect. Now, when we are talking about weak acid, there are those that does not ionize completely in water. They don't ionize all the molecules that is present in them. All the ions that are present in them, they don't ionize it completely in water. Example here is H2CO3. The carbonic acid is a typical example. Also, the ethanoic acid is also another example that we have there. They are a good example of acid that they are very, very weak. They don't ionize completely in water. So in that case, because they don't ionize completely in water, they cannot be used as electrolytes. That's the fact we need to know about them. Strong acid, they can still be used, e.g. the H2SO4. Because it's a strong acid, it will ionize completely. So in that case, they can ionize completely, and they can be used as electrolytes. Now, let us now look at the properties of acid. What are the properties of acid? In the area of physical properties, of acid, the number one properties of acid is that they are sour to taste. Sour to taste. That is to tell you that when you taste acid, they are sour. If you want to know this, just get an unripe fruit, e.g. orange. Get the unripe one. Cut it, then get some little quantity onto your tongue and see what will happen. You see how you are going to squeeze your face. Why? Because they are sour to taste. So, number two, acid turn blue litmus paper red. Acid turn moist blue litmus paper red. Acid turns moist blue litmus paper red. That is another physical properties. If you put acid inside a what? Inside a moist, if you put a litmus paper, moist blue litmus paper, if you put it inside acid, what will happen? It will change to red. So always remember this: ABR. What does that mean? Acid turn moist blue litmus paper to red. That is number two. Number three. The number three properties of acid in terms of physical is that conch acid are corrosive. Conch acid are corrosive. That means they are dangerous. Conch acid are what? Are dangerous. And in the laboratory, that is the reason why you are advised not to add water to acid, particularly sulfuric acid. You are to add sulfuric acid to what? To water. That means you have to grant the water, then add the sulfuric acid to it. Take note of that. It's very, very important. Strong acid are corrosive. They are dangerous. You don't play with conch acid in the laboratory. Now, these are the physical properties of acid that we have there. Now, let us now look at the chemical properties of acid. Chemical properties. Chemical properties of acid. Number one of these chemical properties is that When acid react together with metals, when they react together with metals, there is a form of compound that is always being formed. What is that? Hydrogen is formed, which is hydrogen gas. For instance now, this is zinc. It's a metal, solid. When it reacts together with HCl, which is what? Aqueous. What will happen? It will happen that this one forms zinc chloride plus what? Plus H2 gas. There will be formation of what? Of hydrogen gas here. We are going to have hydrogen gas. This one will be zinc chloride. So this is number one properties of acid. Acid reacts with metals to produce what? To produce hydrogen gas. Reaction with metals. Number two is reaction with non-metals. Reaction with non-metals. For example, when we are talking about non-metals, here we are talking about oxygen, we are talking about nitrogen, and the rest of the compound. Now, in this place, when it comes to the reaction with non-metals, for instance now, when acid reacts together with calcium oxide, e.g., let's use HCl in this place, what will be produced? We are going to have CaCl2, then plus H2O will be produced. So, acid react together with non-metals. In this place now, we have calcium oxide, which is an alkaline. Then, together with hydrochloric acid to produce calcium chloride plus what? Plus H2O. It's a typical example there as well. Also, acid reacts with triazocarbonate to produce carbon dioxide and water. Remember, acid reacts with triazocarbonate to produce carbon dioxide and water, but not carbon dioxide only. A salt is produced alongside. E.g., when we have the reaction that occurs between the Na2CO3, this is a triazocarbonate compound, plus H2SO4, what will be the product formed? We are going to have production of Na2SO4 plus H2O plus CO2. This is gas, this is liquid, this is a salt, also in aqueous form. So, acid reacts together with triazocarbonate, that means between triazocarbonate and what? And sulfuric acid to produce what? To produce salt, to produce water, and to produce carbon dioxide. Now, since we have looked at the chemical properties, the last one that we have there is neutralization reaction. The reaction that we have here is a neutralization reaction, and is the first and foremost number one chemical properties of acid. For instance, when acid reacts together, e.g., we have the reaction between HCl plus NaOH. This is acid. This is alkali. When they react together, they produce what is called NaCl plus what? Plus H2O. What is this? It's a neutralization reaction. What is a neutralization reaction? A reaction between what? Between acid and base to produce salt and water only. You can see this is salt, NaCl, a common salt, and water is being produced from here. Now, all this mentioned are the chemical properties. Now, let us now look at preparation of acid. Preparation of acid. We can prepare acid in the following way. Number one is action of acid, and anhydride in water. Action of an acid anhydride in water. What does that mean? The following are acid anhydride compound: SO2, SO3, NO2, CO2. All these mentioned, they are the compound that when water reacts together with them, they can produce acid. Let's check it one after the other quickly. Here, when this one reacts together with water, what will happen? We are going to have production of H2SO